Welcome to our third lesson. This lesson is on composite functions. So the idea of a composite function. Consider a composite function as a function that is made up of two or more other functions. Okay, so it's like the universal function and then there are subsets of functions within it. So consider two functions, f of x, which is defined as 2x plus 3, and then g of x, which is defined as x squared minus 1. Okay, so to become a composite function, then we will need to put these two functions together. Okay, there are two options. Either we decide to um, work on f first, then we deal with g. Okay, and this is how we write it. So you always start from the right to the left. So you work on f first, then you finish with g. So what this means is that you are putting f into g, okay, to give you a resultant, one full function. All right, or you might want to work on g first, then you work on f. What this means is that you are putting g into f. Okay, all right. So in some books they will say that this is called f followed by g. All right, and this is called g followed by f. What it basically means is that work on the first function, the answer you get, put it into the second function. So we are still working with the functions we have, okay, f of x and g of x. Now, if you are told to work out g of f, what this means is that we are going to put f into g, like I said already, okay? So we are going to put the function of f into g. But what is f of x? F of x is this, 2x plus 3, right? So this means that we are going to put 2x plus 3 into g, okay? But what is g? G is defined as x squared minus 1. So wherever you will see x is where you put the entire f of x, which is 2x plus 3 there. But what do we have? X squared minus 1, that is g, okay? So where we will see x is where we will put 2x plus 3. Now this is x squared, so the entire 2x plus 3 will stand as the x, okay? But remember it is squared, so we will have to square it as well. Minus 1, okay? Then we expand this bracket. So when you expand this bracket, this is what you get. You get 4x squared plus 12x plus 9. Then we have minus 1, okay? So we bring it minus 1. Then we simplify. This is still there. 12x is still there. 9 minus 1 gives us 8. Now let's consider the other way around. What if we are working with fg? So this means we are going to put g into f. But what is the definition of g? G is defined as x squared minus 1. So we are going to put the entire x squared minus 1 into the function f, okay? So your x squared minus 1 becomes the input. So wherever we will see x in f is where we will put the entire x squared minus 1. So what do we get? This is what we get. Remember, we have 2x plus 3. That is the definition of f. But where we will see x is where we will put the entire x squared minus 1. Okay, so we have 2x. That will become 2 into bracket x squared minus 1. All right, we have plus 3. So we have plus 3. Now we expand this bracket. We will get 2x squared minus 2. Okay, then we have plus 3. So we have our plus 3. We simplify this, and what do we get? We get 2x squared plus 1. All right, so this means that if you have g f of x, it is not equal to f g of x. Why? Because when we worked out for g f of x, we got 4x squared plus 12x plus 8. Okay, But when we worked out for g f of x, f g of x, we got 2x squared plus 1. So these are not the same. Order is very important. Okay, keep this in mind. So we have seen certain notations, and there are still notations for us to consider. We have seen fg, we have seen gf, but there is f squared. When you see f squared, it means put f into f. Okay, so you are putting the function f into itself. You always start from the right, so you work on the right one, then you put it on the left one. Okay, then you can also see g squared, so it means put g into g. So you work on g, and then the answer you get, you put it into g. I'll solve an example for you to see. Okay, so consider an example. F of x is defined as x plus 2 all squared minus 1, and it is defined on this domain. X belongs to a set of real numbers. Okay, all right, so you are to work for f squared 3. What this means is that work out f of 3. The answer you will get, put it into f again. Okay, so you are going to work out f of 3. That will become your input. The answer you get, you put into f. All right, but what is f of 3? Now f of 3 means wherever you see x, put what there? 3, and that is what we are doing. So wherever we see x, we put 3 there. Okay, so we have 3 plus 2 all squared minus 1. That is the definition of f. But see, this is for this function, okay, f of 3, but there's another function f, so please keep it there. Now this will give us 5 squared minus 1, right, which is 25 minus 1. Answer will be 24. Okay, 24. So now we have 24 here, so we have f of what? 24. What this means is that we will put 24 into the function f again. Why? Because we are working with two f's, right? It's f squared. So we are done with the first part. So our new answer, which is 24, we will put into this function again, which means wherever we see x, we put 24. So we have 24 plus 2, making 26. So 26 squared is 676 minus 1 will give us 675. All right, so you should try this one out. You have f of x, which has been defined as this over this domain, and then g of x is defined as this over this domain. Your job is to find g f of 18. So I'll give you a few minutes to solve, after which you can unpause this video to check out your answer. All right, I hope you are done by now. So our job is, like I said from the beginning of this lesson, you always start from the right, and the right is f of 18. Okay, so let's go and work out for f of 18. So f of 18 will give us 1 plus root of x, right? But we are dealing with 18, so we put 18 there, minus 2. So 18 minus 2 gives us 16, but root of 16 is 4. 4 plus 1 is 5. Then this answer is what we will put into the g. Okay, don't be confused. You will work for f of 18. The answer is what you put into the last function, which is g. Okay, so g of 5. Okay, g of 5 is we putting 5 in place of x. So 10 divided by 5 will give us 2. 2 less 1 gives us 1. All right. So in our next lesson, we shall solve more examples on composite functions. Okay, there will be some examples that we solve, and then the equation will become a quadratic for us to simplify further. I hope to see you in the next lesson.